After a year on testnet, a London-based team of coders has finally launched a set of contracts known as Aztec. The contracts use zero-knowledge proofs to create complete privacy in as far as no one can see who transacted with who or how much was moved within the smart contract. We had a look at it when it was on testnet, with the smart contract described as basically a database of its own where who owns what and how much is sort of kept in a black hole that is not accessible to the blockchain. Now this has gone live on the 31st of January, with a set of smart contracts bringing Zcash-like privacy to Ethereum tokens and potentially dApps. Aztec relies on zero-knowledge proof validators on-chain, which can be difficult to use on their own, says Arnaud Schenk, tech lead at Aztec. Describing one of the smart contracts, he says ACE abstracts the complexity away, so that developers and asset issuers can easily deploy Zcash and dApps. This Zcash talks to ACE, whose job is to validate ACE proofs and implement some of the trickier pieces of logic to allow for Zcash transfers and public less than greater than private asset conversion. You need to deposit DAI through this Zcash detailed contract through a zero-knowledge proof. Aztec turns DAI into what can be described as a smart contract database asset. You send the DAI to Aztec, and you get Zcash, which gives you a claim to the DAI. You can transfer the Zcash within the smart contract environment, but the blockchain won't know until you convert it into DAI. In the meantime, you're exchanging value in a very private manner. End users can quite play yet with Aztec because an app is not out, but devs can incorporate it through a tutorial of sorts. We're relaunching an easy user interface. In the coming weeks. For now, our main product is our MD, aimed at developers. Schenk says. The UI will be built on top of this MD as a demo. Once that goes out, then presumably this can be as easy as turning private mode on and off where end users are concerned. For dApps, the matter seems to be a bit more complicated. The simple solution is to wrap TDREI. We will be releasing more tokens in the coming weeks, including interest-bearing tokens. Users will then be able to wrap those tokens into their confidential form. Joe Andrews, at JSF, February 6, 2020. In short, building these systems with private assets is more complex, since most currently rely on collateral being public for liquidation, says Schenk. This is all open source, however. So while it might be complicated for DeFi where devs are concerned, how easy it would be to synergize presumably depends on the nature of the dApp. The Aztec ceremony this uses zero-knowledge proofs, a new area of cryptography where through very advanced maths you can prove the right to something without revealing what that something is or the amount. To do this magic you require a ceremony to create a large number of points with mathematical relationships to one another, called monomial points. The system is secure if just one key is destroyed, or if only one participant behaves as they should, with considerable public testimony of attendance for the Aztec ceremony. Happy to have participated as Aztec Ignition Trusted Setup Ceremony Participant #1. Ethereum address, ekbefddzaest transcript hash, /t. Olorado/xizigek Vitalik. Vitalik Buterin, February 7, 2020. The ignition ceremony was a multi-party computation (MP) ceremony, Schenk says, adding, "We completed ignition in early January, after 176 individuals and institutions from over 30 countries took part." The output of ignition is a public resource, and can be used by other teams building crypto systems. Vitalik took part as participant #1, and built his own custom implementation of the ceremony software. We had an open call for signups, and during the ceremony, anyone could make a one-way transaction to get a slot. Trusted setup. While this new tech is pretty cool, Bitcoiners would argue that because you can key validate yourself, you can be sure apes. You can read full post on Cryptophans. News link available in text below.